Hello everyone, welcome to our YouTube channel Logic Medico. Today's interesting topic is mechanics of respiration. If you are new to our channel, kindly consider subscribing to our channel, pressing the bell icon to get the latest video, thumbs up icon if you like the video, share this video with your other friends. So let's start with mechanics of respiration. So the major respiratory organ is the lungs. So the process of, this is the lung, the process of drawing in of the air into the lungs is called as inspiration. So at the end of inspiration, the lung is going to expand. So here you can see the lung has expanded. After that, the elastic fibers present in the wall of the lung will recoil, thereby pushing the air out. It is just a passive process. So the air inside the lung will go out, and this process is called as expiration. Inspiration is an active process wherein energy is consumed. Expiration is a passive process because it is just a recoil of the elastic fibers present in the wall of the lung. We can see this muscular partition, it's called as diaphragm. During inspiration it has come down, during expiration it will go up. So the details of this we'll understand now. So the lung can be compared to the balloon. Here the balloon has bloated up. So this is inspiration. When the air goes out, the balloon is becoming small. So that is expiration. So the balloon is compared to the lungs. This is an analog. So after understanding the analog, the balloon which was there, while blowing the air we require energy. While the air goes out by itself, that is because of the elastic recoil of the rubber present in the wall of the balloon. Here it is elastic fibers. So the mechanics of respiration, there are three mechanisms of respiration. First we have to understand the position of the diaphragm. Diaphragm is a muscular partition which is present between our thorax and abdomen. In our body, the upper portion is called thorax and the lower portion is called abdomen. At the junction between the two, there is a diaphragm. It should be muscular partition. It should be like this, that is horizontal. But here we can see the domes of diaphragm because the lungs are spongy organs. Below the right lung will be liver, 1.5 kilo. So it is pushed 1.5 kilo against some 200 grams. Okay, so it is pushing the lungs, the spongy structure. So it becomes the right dome. Below the left dome of diaphragm, there will be a spleen, approximately 350 gram. So that will push against the left lung. So there is one more dome, not as big as the right dome. So that is the left dome of diaphragm. This diaphragm is a muscular partition between thorax and abdomen. During inspiration, the diaphragm muscle contracts and it shifts downward like this, similar to a piston. The piston, when you pump, the cycle pump piston, it will go down, right? So the pressure inside this will increase, but the pressure here reduces. Similarly, the pressure in the abdomen increases, but the pressure in the thorax reduces. So this negative intrathoracic pressure in the thorax will draw the air into the lungs. So this process is called as inspiration. Which diameter of the thorax do you think is increasing in this piston-like movement of the diaphragm? I'll give you option if you want. Is it the transverse diameter? Is it anterior-posterior diameter or vertical diameter? If you have guessed vertical diameter, then you have told the correct answer. The diaphragm moves down like a piston, increasing the vertical diameter of the thorax, thereby causing negative intrathoracic pressure and thereby inspiration. So normally during a quiet respiration, that is when you are not breathing much, when the breathing is happening automatically, that time only diaphragm is a inspiratory muscle. If you are doing some strenuous exercise, some vigorous activity, that time the intercostal muscles comes into the play. So we know that we have 12 ribs on either side of our body. This is the sternum, which is the chest bone. This is a vertebral column which is behind. So behind means posterior, sternum front means anterior. It's a 3D diagram. This is a rib like this. There are 12 ribs on either side. I have just shown one rib. So between the ribs there are intercostal muscles. When the muscles contract, they act from above and pull the rib upwards. So when the rib which is there like this, I am showing on the other side, that is the right side for the patient. When the rib is pulled upwards like this, over there I have shown in the diagram, here I am showing in animation. When the rib is pulled upwards, so obviously don't you think the diameter is increasing? This can be compared to a dynamic bucket. This is the bucket and this is the handle. The bucket is compared to the dynamic thoracic cavity. Here the volume of bucket does not increases, but the volume inside our thorax will increase. The rib is comparable to the handle of the bucket. So when each intercostal muscle contracts, all the ribs will move upwards. So in such a way, which diameter of the thorax is increased? I'll give you option. Is it the vertical diameter, transverse diameter, or anterior-posterior diameter? If you guessed the transverse diameter, that means you have told the correct answer, because the rib on this side as well as that side increases. So the transverse diameter of the thorax increases. In such a way, creating a more negative pressure inside the thorax, causing a deeper inspiration. This movement or this mechanics of respiration is called as bucket handle movement. So until now we have finished with piston-like movement, that is facilitated by diaphragm, and bucket handle movement, which is facilitated by the intercostal muscles, where the thorax is comparable to a bucket and the ribs are comparable to the handle of the bucket. Bucket handle movement. Last but not the least is this movement. It's the same rib, I know, but we have shown in a different view. This is a lateral view of the thoracic cage, where I should show you 12 ribs, 12 pair of ribs, 1, 2, like this, 12. I have just shown one rib. In the anterior plane or the front, I have shown you the sternum. In the posterior plane, this is the vertebral column, thoracic vertebral column. This is posterior, that is back, that is anterior, that is front of the body. Rib is there connecting the vertebral column to the sternum. Like this 12 rib will be there. Okay, here the intercostal muscle, when they contract, the sternum, the chest bone is there in the front anterior midline, that will be pulled forward like this. Okay, it's shifted more anteriorly. The dotted line is the future position. The rib, which is obliquely oriented like this, upon intercostal muscle contraction, the rib will be more horizontal. Instead of being oblique, it will be more horizontal. The sternum, instead of being here, it will be more anteriorly shifted. So this movement can be compared to the pump handle movement. I am sure you would have seen some water pump in some areas. Okay, the pump and the handle. So what happens when you lift the handle? Of course water comes, so that's relevant here. So when you shift the handle like this, obviously a diameter is increasing. Which diameter? Option again, vertical, transverse, or anterior-posterior. If your answer is anterior-posterior, then you are correct. This kind of movement of the intercostal muscle and ribs, elevation of the ribs in such a way the sternum is shifted further forwards, causing increase in anterior-posterior diameter, again causing negative intrathoracic pressure. Inside the thorax, pressure is becoming negative. This draws the air into the lungs, causing inspiration. This kind of movement is called as pump handle movement. In summary, the mechanics of respiration are 3: piston-like movement, bucket handle movement, pump handle movement. What is this piston-like movement? It is facilitated by diaphragm. The diaphragm shifts downwards, increasing the vertical diameter similar to a piston, thereby facilitating negative intrathoracic pressure and inspiration. What is bucket handle movement? The bucket here is comparable to the dynamic thorax. The handle is comparable to the ribs. So if you see, the elevation of the ribs by the intercostal muscles will cause increase in the transverse diameter of the thorax, thereby negative intrathoracic pressure, thereby inspiration. This is called as bucket handle movement. If you see the same thoracic cage from the lateral view, we have the sternum anteriorly, vertebral column posteriorly, and the rib in between the two. When the intercostal muscle contracts, in such a way the ribs are elevated, the sternum shifts forwards, thereby increasing the anterior-posterior diameter. This is comparable to a pump and a handle. Try to lift the handle of the pump, of course, it goes further away from the pump. So that the anterior-posterior diameter of the thorax is increased, causing negative intrathoracic pressure, causing more deeper inspiration. This is also caused by intercostal muscle. This is in detail about the mechanics of respiration. Thank you for watching and learning from Logic Medico. Kindly consider subscribing and press the thumbs up icon if you like the video. and bell icon to get the latest notification of the videos, and share this video with your family and friends. Thank you very much. Bye.